Assalamualaikum dan salam sejahtera. In this video, we will be discussing lecture 2 about arithmetic sequence. Okay, look at our learning outcome. By the end of this video, student should be able to find the nth term of arithmetic sequence and series Tn equal to a plus n minus 1 times d, and use the sum formula Sn equal to n over 2 2a plus n minus 1 times d, or second formula Sn equal to n over 2 times a plus l. Before we go deeper in these topics, you should know the introduction of arithmetic sequence. An arithmetic sequence is a set of ordered terms of the form a plus d, a plus 2d, a plus 3d, and onwards, where a is the first term and d is the common difference of the sequence. So the nth term of an arithmetic sequence is given by the formula Tn equal to a plus n minus 1 times d. And the sum of the nth term of arithmetic series Sn equal to n over 2 2a plus n minus 1 times d, or if we let the last term l equal to a plus n minus 1 times d, so from the first formula become the second formula Sn equal to n over 2a plus l. So there are two formula sum of the nth term of arithmetic series. First formula and second formula. Okay. This is the example of arithmetic sequences. So you can go through by your own arithmetic. This is example of arithmetic sequences. Next, we go to the relationship between the sum of the terms of a series and the value of the actual terms. The summation of the first n minus 1 term is denoted by Sn minus 1. And the summation of the first n term is denoted by Sn, where Tn is the n term and d is the common difference. So we observe Tn equal Sn minus Sn minus 1, and the common difference equal to Tn minus Tn minus 1. This is important formula. Okay, next we go to example 1. In an arithmetic sequence, the 10th term is 3. So given the 10th term T10 equal 3, and the sum of the first 6 term is 76.5. The sum of the first 6 term S6 equal to 76.5. So the question asks you to find A the first term T1 or equal A and the common difference D. Question B, find the smallest value of n such that Sn less than 0. So find the smallest value of n such that Sn less than 0. Okay. Okay, look at the solution for example 1a. Okay. So, for example 1a, given the 10 term T10 equal 3. Then substitute into Tn formula. What Tn formula? A plus Tn formula is A plus n minus 1 times D. So, substitute into Tn formula A plus, so T10, 10 minus 1, 9D equal to 3. We let this as first equation. And the question given the sum of the first 6 term as 6 equal 76.5. Then using Sn formula, Sn equal to n over 2, 2a plus n minus 1, n is 6, so 5d equal to 76.5. Okay, so n over 2, sorry, 6 over 2. Then we simplify the equation, become 6 12a, 6 over 2, 3, so 6a plus 15d equal to 76.5. We let this equation as second equation. Then solve equation 1 and 2. One and 2 simultaneously. We get solve simultaneously. We get the value of A is 16.5 and the value of D is negative 1.5. Okay. Okay, this is solution for part A. Next, question B. For example 1b, given the smallest value of n such that Sn less than 0. Okay. The formula Sn for arithmetic sequence n over 2, 2a plus n minus 1 times d less than 0. Then from the part A, substitute value A and D from part A, n over 2, so 2 Value from part A is 16.5 plus n minus 1 and common difference negative 1.5 less than 0. Okay, next we expand and simplify n over 2. The 2 times 16.5 is 33 minus 1.5 n plus 1.5 less than 0. Okay, n over 2, 33 plus 1.5 is 34.5 minus 1.5 n less than 0. Then bring to the right, so n 34.5 minus 1.5 less than 0. Okay, so to solve this inequality, apply graphical method. So before I apply graphical method, I multiply both sides by negative n times 1.5 n minus 34.5. Then since we multiply both sides by negative, then the sign also change to greater than 0. Okay, next, by using graphical approach or graphical method, draw the graph. So these two value is n equal to 0, empty circle, less than greater than, so n less than 0, n equal to 0, and the second value is 1.5 n minus 34.5 equal to 0, so n equal to 23. So this sign is greater than, we choose more than. So from the graph, the solution is n less than 0 or n more than 23. Since n must greater than 0, okay, since the value of n must greater than 0, so the smallest value from this interval, n more than 23, so starting from 24, 25 and onwards, so the smallest value of n is 24. Okay, so this is solution for example 1b. Okay, next we proceed example 2. Okay, example 2, find the sum of all integers between 0 and 200, between 0 and 200, not inclusive 0 and 200, that are not divisible by 4. Okay, so to solve this question, okay, you must follow 2 steps. The first step, okay, the first step, list all the integer between 0 and 200. List all the integer between 0 and 200. So between 0 is 1, 2, 3, 4 until between 0 and 200. So the last term is 199, not inclusive 200. So from 1, 2, 3 until 199, so this sequence has 199 terms, or n equal to 199. So n equal to 199. Okay, you look this sequence, first term to second term is at 1, second term to third term is at 1, third term to fourth term is at 1, same common difference. So this sequence for arithmetic sequence. Okay, next you find the sum for all integers between 0 and 200. So using Sn formula for arithmetic sequence, so Sn formula is the sum for 199 term, so S199. So the formula is n over 2, where n is 199 over 2, 2a, 2, and the first term for this sequence is 1 plus n minus 1. So 199 minus 1 is 198 times d. So the common difference is 1. Okay. Then using calculator, 199 over 2. 2 plus 199 is 200. So we get the sum for all the integers between 0 and 200 is 19900. Okay, this is for part 1. Okay, next, step 2, because the question asks you to find not sum all the integers, sum of all integers between 0 and 200 that are not divisible by 4. Okay, next step, you list all the integers between 0 and 200 that can divisible by 4. This all between 0 and 200 that can divisible by 4. So numbers divisible by 4. Okay. So between 0, so number divisible by 4 is starting with 4. So second term is 8. Next, third term is 12. And what the last term? Between 200, between 0 and 200, not inclusive 200. So the last term is 196. Okay. From this sequence, checks either this sequence is arithmetic or not. Okay. So first term 4. First term to second term is plus 4. Second term to third term is plus 4. Same common difference. So this is arithmetic sequence. This is arithmetic sequence. This is for the arithmetic sequence. For the arithmetic sequence, numbers divisible by 4. Okay, where the first term A is 4 and common difference D equal to 4. So how many terms? How to find N? How many terms? So to find the number of terms, we use Tn formula. We know the last term is 196. So to find N, the number of terms using Tn formula, Tn for arithmetic sequence is A plus N minus 1 times D. So the last term is 196. Okay, first term is 4 N minus 1 and the common difference is 4. Then using calculator, you solve this equation, we get N is 49. So we know this sequence has 49 terms. So to find the sum for this sequence using formula summation for arithmetic sequence, so what formula? Sn equal N over 2, so S49 equal 49 over 2, 2A plus N minus 1, 49 minus 1 times D. Okay, so using calculator, so we get the summation for this arithmetic sequence is 4900. Okay, so the question asks you to find the sum of all the integers between 0 and 200 that are not divisible by 4. Okay, so thus the sum of all integers between 0 and 200 that are not divisible by 4 is S199 minus S49 equal to 19900 minus 4900. Using calculator, the answer is 15,000. Okay. Okay, next we proceed to example 3. Example 3. The sum of the first n term of an arithmetic progression is given by Sn equal to Pn plus Qn square. Given that Sq equal to 6 and S5 equal to 11. Find find the value of P and Q. B, find the n term and the value of its common difference. Okay. So look, I show you the solution for question A. Okay, example 3A. Okay. Given the sum of the first of an arithmetic progression is Sn equal to Pn plus Qn square. Given that S3 equal to 6, so S3 equal to 6. So by substituting 3 into this Sn, we get 3p plus 3 square 9q equal to 6. Okay, then we simplify. Divide both sides by 3. P plus 3q equal to 2. Okay, we let this equation as equation 1. And given S5 equal to 11. By substituting 5 into Sn, we get 5p plus 25q equal to 11. Okay, then we let this equation as equation 2. Okay, to find the value of P and Q, okay, by solving equation 1 and 2 simultaneously, 1 and 2 simultaneously, okay, we get the value of P is 17 over 10 and Q equal 1 over 10. Okay, so this is solution for part A. Okay, for part B, find the nth term and the value of its common difference. So, question given Sn is Pn plus Qn square. So, to find the nth term, using the formula Tn equal to Sn minus Sn minus 1. Okay, so given Sn, okay, find Sn minus 1. Sn minus 1 is substitute n minus 1 into n. P n minus 1 plus q n minus 1 square. Okay, then substitute into Tn. So Tn equal Sn Pn plus Qn square minus bracket, open bracket, Sn minus 1, okay, Pn minus 1 plus Qn minus 1 square. Okay, so we simplify Pn plus Qn square minus Pn minus P plus Q n square minus 2n plus 1. Okay, Pn plus Qn square plus minus Pn plus P minus Qn square plus 2nq minus q. Okay, cancel Pn, we can cancel Pn, Qn square, okay, P plus 2nq minus Q. Tn, we get Tn equal P plus 2nq minus Q. Then substitute P and Q obtained from part A. Substitute P and Q from part A. So from part A we get P is 17 over 10 plus 2 and Q is 1 over 10 minus 1 over 10. Okay, 17 over 10 minus 1 over 10 is 16 over 10 plus 2n over 10, and simplify 8 over 5 plus n over 5. So therefore we get Tn is 1 over 5 8 plus n. Okay. And the common difference D equal Tn minus Tn minus 1. Then substitute Tn 1 over 5 8 plus n minus Tn minus 1 1 over 5 8, substitute n minus 1 into n plus n minus 1. Okay, then we simplify 8 over 5 plus n over 5 8 plus minus 1 minus 7 over 5 minus n over 5. Okay, so can cancel n over 5. So 8 over 5 minus 7 over 5 is 1 over 5. So the common difference is 1 over 5. Okay. A series is the sum of the term of a sequence. The n partial sum is Tn equal to Sn minus Sn minus 1. An arithmetic sequence, this is arithmetic sequence, the n term of arithmetic sequence is Tn equal to A plus n minus 1 times D. Okay. The sum of the arithmetic series, there are two formula, Sn equal to n over 2 to A plus n minus 1 times D. And the second formula is Sn equal to n over 2 times A plus L. Okay, thank you.